All right, so now we go into our second lesson of exponents, and now we're going to be dealing with brackets and coefficients and how we handle that. So up until this point, we've done quotient rule, we've done product rule, but now we're going to add in this new rule that deals with powers and powers, which is the power rule, or specifically when we have brackets around our exponent terms. So let's consider the following example. Well, from the previous lesson, we know that an exponent means we write out whatever the base number is, however many times the exponent is. So in this case, we have a bracketed term of 5 squared, and it's to the third power, which means we write out that 5 squared 3 times. By product rule, we would know to add these exponents. But here's where we introduce this new rule called the power rule. The power rule says that if we have some base to some exponent and it's raised to another exponent, we're going to multiply these. Or if we have an existing power, then the product of the exponent inside and in the brackets to outside the brackets is going to be represented by the multiplication of those. So let's look at our first example here. Simplify the following powers. I have 2 to the 3 to the 4th power on the outside. By power rule, this means I'm going to multiply the 2, and I have a base of 2 with 3 times 4 in the exponent. 3 times 4 is 12, and we have 2 to the 12 as a final answer. If I look at B, it's going to apply the same way. I have m to the 2nd power, but by power rule, we multiply our exponents, and this is equal to m to the 14. For part C here, we're going to do the exact same thing here, but when we know we have a fraction of some kind, this exponent will apply to both exponents within the brackets, meaning I have m 2 times 5, which is 10, all over n 3 times 5, which is 15. And we're done there. Now, same kind of concept with this next one. We have an exponent with 2 things on the inside. I'm going to multiply those exponents there. This is going to give me x 3 times 4, which is 12, y 6 times 4, which is 24. And that is our simplified solution there. Now, in our part E here, we have x to the 8, x to the 4 squared, x to the 3 to the 6th power. What I can do with this one is I can say, what if I use product rule on the inside? So I'm going to use product rule first, and then I'm going to deal with that exponent on the outside. So in my numerator, this is going to be equal to, and maybe I'll go back here for just a second. This is going to be equal to, I have x8 times x4, a common base of x, and then we add the exponents here. So I should have this is to the power of 12. I keep my brackets because I haven't dealt with this exponent on the outside. I use product rule to simplify the interior, all over x3 to the 6th power. Now this is equal to, by power rule here, we went from product in the first step to power rule now. I have x 12 times 2, which is 24, all over x 3 times 6, which is 18. And now I have the quotient rule from our last lesson. Quotient rule says that if I have a common base over a common base, I do x 24 minus 18. I subtract the 2 exponents. Therefore, my solution is x to the power of 6. All right. Now, if we're dealing with coefficients here, coefficients add another layer of complexity. If I'm dealing with, considering the first case here, or dealing with coefficients, let's look at this first case below, signified by blue. I have 3m squared times 4m to the 3rd power. Well, that 3 is not attached to the squared, and the 4 is not attached to the 3rd exponent. There's no brackets around these terms, so the 4 and the 3 are secondary, and there you just get multiplied together and become the coefficient term here. Whereas in the piece that's going to be represented by red here, if my number is in the brackets to that exponent on the outside, it means that it is applied to that exponent. So we have to actually square the 3 value as well and then continue forward. So we know that if there's a term that's bracketed, the exponent will also apply to it. So consider the following example here. 2m squared to the 3rd power, we distribute that that exponent to both of these, including the coefficient. So we have to do 2 to the 3 m to the 2 times 3, which is m6. All right, let's piece this together here for some examples. So if we simplify these by the powers, well, first of all, I'm looking at the coefficients and saying, are they attached to the exponent? In this case, no, because they're not in brackets and connected to that exponent. So I'm just going to use standard multiplication and say this is 3 times 5, which is 15. And then I have an A4 times an A2. By product rule, we have a common base, and I add 4 plus 2, which is 6. I move on to my part B here. I know that if it's not listed, my power on each of these is 1. If there's not a power listed, it's 1 for both of them. And by power rule, I'm going to distribute this 3 to both of those powers. That means I have 3 to the power of 3 and x to the power of 3. And 3 to the power of 3 is going to be 27, and x to the power of 3 can't be simplified anymore. If I look at C, it applies the exact same way. If not listed, the exponent on any number or variable is 1. I distribute by power rule to my exponents, and this is going to give me 2 to the 4th power times y to the 2 times 4, which is 8. This is equal to, well, 2 to the 4th power is going to be 16, and y to the 8 can't be simplified anymore here. All right, I'm shifting over to D here. Now, here's something we discuss a lot in class, and it's discussed a lot. If you have a negative value or a negative coefficient here, and it's raised to an even power, in this case 2, that negative will become positive. Here's why. If I square a number, or I fourth a number, or I sixth a number, what am I doing? I'm writing this out however many times. So in this case, I've negative 3a3b to the 4, and I write it out 2 times because we're squaring it. Everything in the brackets is being written twice. Now, if this is the case, by the coefficients here, we have a negative 3 times a negative 3. Negative 3 times negative 3 gives us a positive 9. So if we raise it to an even exponent, or a negative to an even exponent, it becomes positive. Now I have a3 times an a3, common base. By product rule, I add the exponents together, so this will be 6. Then I go b, which is the common base, and by product rule, I add the exponents, and that becomes 8. And that is my solution. All right, and then we deal with E here. I'm always looking to handle my coefficient terms first, or my number coefficient terms first. 18 over 3, if I divide this, 18 over 3 is simply just 6, or 18 divided by 3. x9 over x1. By quotient rule, we're going to subtract the 2. x9 minus 1, that's going to give me x to the power of 8. And then I have y. Well, y6 over y5, that's 6 minus 5, gives me y to the power of 1. Now, you could either write that 1 in there, or you could erase it. Either way, but if you show it, that's totally fine because it means the exact same thing here. All right, so here's your check your understanding section. These are the problems for you to work on based on the power rule we just discussed. Now, this may include the quotient or the product rule, but just know that even with those two added, now we have to stack them together and say, okay, if I have a power rule going on, I'm going to first try and deal with that power rule if possible, or do either quotient or product if necessary.